This is my lab report for Lab 1. For this lab, we are observing an object moving at a constant speed and direction. We used the Tracker app to record the motion of the object, and we created a model using code. We then compared the tracker motion to the model, and I found that the tracker motion was showed to taper off a little bit at the end when the model did not. The main physics principle we used for this lab was an object in motion will stay in motion unless acted upon. Here's a video of the experiment. For this experiment, we pushed an object so it moved at a constant velocity. The initial condition for the experiment in the model was when the model was already at a constant speed, so the net force was 0. The system in this experiment is the cart, the object moving, and the surrounding is everything except for the cart. This is the model I created using code. For this model, the blue ball represented the cart and the yellow ball represented the initial position. Potential sources of error were that the camera was not parallel to the track and that the actual speed was not constant due to things like friction, the push, or the tilt of the track. For the code, the most important parts was that I set the initial variables to the data I got from the Tracker app, including the initial position, velocity, and the time every picture for the camera. I then created a while loop in order to calculate the ball position at every 0.033 seconds, because that's how often the camera took a frame. And I did this using the position update formula. This is the graph I created representing the actual and the model of the movement and position of the cart. The blue is the actual and the red is the model. The model is completely linear because of the code and it didn't have any errors. So that's why the coefficient determinant is 1. The actual is affected by friction, causing for a lower coefficient determinant because it wasn't perfectly linear. For the questions, how would the results change if the axes were flipped? If we flipped over the if we flip the axis over the x-axis, the equation would turn to a negative slope. If we were to rotate the axis so the x-axis became the y-axis, it would have just switched. All we would have to do is switch the x and y positions to get the proper equation. How many forces are being added together to get a 0 net force in the case you were observed? The force of gravity pulling the cart down is counteracted by the track pushing against the cart up. And this turns out to be the same force, so the cart does not go up or down. The force that caused the velocity is no longer acting on the cart and cannot be calculated from the information in this experiment.